Welcome to the Deep Dive. Today we're plunging into, well, one of humanity's oldest and maybe most profound questions. Is our future predetermined, or is it purely a matter of chance?
It's a dilemma, yeah. Puzzled thinkers for centuries. But, as we've seen in the material you shared, the truth is uh, way more complex than just either.
Right.
It seems to be governed by this fascinating and very complex mathematics that kind of blends predictability and surprising chaos.
That's a perfect way to put it. And the material really dives into chaos theory, which, well, it's often misunderstood, isn't it? But it's been called the third great theory of the 20th century.
Alongside quantum physics and relativity, yeah.
Exactly. What makes it so foundational, to put it up there with giants like that?
What's really fascinating, I think, is that chaos theory isn't just about, randomness or disorder. It's more a universal law.
Okay.
The law of nature that explains how this deep unpredictability can actually pop up from perfectly deterministic rules. So our mission for this deep dive is to unpack that, show you how it operates from, tiny everyday things right up to planets moving, and what that means for how you think about fate, prediction, the limits of knowledge. Get ready for some aha moments, hopefully.
Okay, let's unpack this. So when we talk about chaos in science, we're not just talking about, complete random disorder. Our deep dive shows chaos theory as this really fascinating concept, a dynamic system sensitive to initial conditions. What's the key takeaway there? What does that sensitivity really mean?
It means that even the absolute tiniest, almost imperceptible changes right at the start can lead to dramatically different outcomes down the line, often totally unpredictable ones. Think about a wisp of cigarette smoke, how it shifts with just a tiny breath.
Right.
Or a flag flapping in the wind, you never know quite how. Or even ocean currents, planets. They can change their paths based on every little thing. These are everyday examples of that extreme sensitivity.
And this leads us right to the famous butterfly effect. A lot of people probably know it from that Ray Bradbury story, The Sound of Thunder.
Yeah, the one where crushing a prehistoric butterfly just completely changes the future. Classic.
Where did the idea come from scientifically?
Well, it actually emerged from a scientific paper. The idea proposed was that theoretically, a butterfly flapping its wings in Brazil could actually contribute to either causing or maybe even stopping a hurricane over in Texas. The core idea is just that these seemingly tiny actions, tiny variations at the start, can trigger this cascade.
Right, a chain reaction.
Exactly, leading to massive, disproportionate, and completely unforeseen results.
Now, this whole idea of chaos, it feels like it clashes pretty hard with the classical idea of determinism. Isaac Newton picturing the universe like a giant billiard table.
Where if you knew the exact position and speed of every single ball, every particle, you could, in theory, predict its future forever. Total clockwork.
And then there's Laplace's demon, too.
Indeed. Pierre-Simon Laplace, he proposed this hypothetical, super intelligent demon. And this demon, knowing the state of every particle in the universe, could see all future and all past events. Perfect clarity.
Wow.
It's the ultimate expression of complete determinism, basically suggesting the whole fate of the universe is a movie it has spoiled for itself.
But here's where it gets really interesting. What we found digging into this material, it reveals this central paradox. The universe is somehow simultaneously determined and completely unpredictable. How can both possibly be true? That feels like a major contradiction.
That's a really fascinating distinction, because while our big macroscopic world is fundamentally governed by cause and effect, each moment follows from the last, our actual practical ability to predict the future, it's severely limited. Especially for these chaotic systems, we're often talking just a couple of days, maybe?
Only a couple of days.
Before that butterfly effect just completely messes up all the cards, as the source puts it.
Yeah.
And this isn't just some abstract idea. It really changes how you think about control, about uncertainty in your own life.
So let me see if I've got this right. Even if, in theory, everything is predetermined down to the particle, for all practical purposes, it basically behaves as if it's not.
Precisely. We, as human observers, we simply can't measure initial conditions with infinite accuracy. It's impossible.
Okay.
And the slightest, tiniest measurement errors, they just escalate exponentially in these chaotic systems. So even if the universe is fundamentally deterministic deep down, the practical impossibility of getting perfect data means that, for us.
For us, yeah.
The future of chaotic systems stays fundamentally unpredictable beyond a really short time horizon, which means fate isn't some fixed script. It's more like a dynamic, unfolding result. It's a powerful idea, really.
Let's try and bring this to life then with some unbelievable examples that came up in our research. First off, this incredible story of Tsutomu Yamaguchi. He's been called the luckiest and unluckiest man in the world.
Why? It's an astonishing story. He was officially recognized by the Japanese government as having survived both atomic bombings, Hiroshima and Nagasaki in 1945.
Both.
He was in Hiroshima on a business trip about 3 kilometers from the epicenter when the first bomb hit. He got serious injuries, burns.
Wow.
But despite that, he managed to get back to his home city, Nagasaki, and just 3 days later, he's literally describing his experience in Hiroshima to his boss.
No way!
And the second bomb explodes, again, about 3 kilometers from where he was.
That goes way beyond just bad luck, doesn't it? It really shows this chain of very strange events where every little thing was decisive. Just tiny decisions, timings.
Absolutely.
And speaking of decisive little things, the story of how Kyoto was spared from the bomb is just, you won't believe it.
Yeah, that's another incredible example. The original target was Kyoto, not Hiroshima, a major cultural center.
Right.
But Henry Stimson, who was the U.S. Secretary of War at the time, well, turns out he'd spent his honeymoon in Kyoto way back in 1893.
His honeymoon, decades earlier.
Over half a century earlier. And apparently he had this deep personal appreciation for the city's beauty, its temples. So he personally intervened, took it off the target list.
So that personal memory, that feeling, that acted like a butterfly wing.
Exactly. It redirected history, made Hiroshima the primary target instead. It just highlights how these very personal preferences, even feelings of influential people, can have these monumental, totally unforeseen consequences for millions.
Okay, now for something we all deal with every single day, the weather. Why is it just so incredibly hard to predict accurately?
Weather. It's like the poster child for a chaotic system.
Right.
Even the simplest weather models, they use these nonlinear equations where basically everything is connected to everything else. It's like trying to navigate a labyrinth that's constantly shifting around you.
So a tiny change makes a huge difference.
A minuscule change. One source mentioned a difference of just 5/millionths of a degree in the initial temperature reading.
Wow.
Could lead to completely different weather patterns just a few days later. The difference between wearing shorts or needing, warm pants.
That's wild. It really is striking. We can predict lunar eclipses thousands of years ahead, down to the minute practically, like that ancient Greek device, the Antikythera mechanism, could do.
Amazing piece of engineering, yeah.
But we struggle to reliably predict rain tomorrow. So, does this inherent chaos in weather, does it mean even something as vast and seemingly orderly as the cosmos isn't immune?
Well, that contrast, eclipses versus weather, it really highlights a fundamental limit. It's not just about better computers.
Okay.
Celestial bodies, like the Earth and Moon, it's often a stable two-body problem, relatively predictable. But weather, that's all about turbulence and extreme sensitivity to initial conditions. Yeah. The sources even cheekily suggest that theoretically someone farting in another room could contribute to a hurricane forming somewhere else eventually.
Chuckles. Okay, maybe a bit extreme, but it makes the point.
It does. It shows predictability isn't universal. It really depends on the system's basic nature.
So even the cosmos isn't totally immune then?
Not at all. There are models suggesting that maybe 4 billion years ago, Uranus and Neptune might have actually swapped places.
Swapped places? How?
Possibly due to a passing asteroid just subtly tweaking their gravitational fields over time. And then you have the classic 3-body problem in physics.
Right, I've heard of that.
While 2 bodies orbiting each other can be stable and predictable, the moment you add a third body, it often leads to utter chaos.
Utter chaos.
Yeah. Bodies scattering, orbits constantly changing, never settling down. It's like that old Russian fable of the swan, the crayfish, and the pike, all tied together with gravity strings, each pulling in a different, unpredictable direction.
And the research had an incredible specific example with Mercury, didn't it?
It did. Scientists ran something like 2,000 computer simulations of our solar system's future.
Okay.
And they changed Mercury's starting distance from the sun by less than a millimeter. Tiny, tiny change, like a cosmic butterfly effect the size of a bacterium.
Less than a millimeter. What happened?
Over 5 billion simulated years, this minuscule difference led to drastically different outcomes. In about 20 simulations, Mercury either got swallowed by the sun or it crashed into Venus.
Wow.
And in one simulation, just one, its chaotic orbit actually destabilized the entire inner solar system. Mars got ejected, Earth potentially colliding with Venus, utter havoc from a millimeter change billions of years earlier.
So we've seen chaos on this grand cosmic scale, planets potentially going haywire. But what about something closer to home, like in the kitchen sink? Let's talk about fluids. The material describes laminar flow as this perfect order, right? Like a smooth, steady stream.
Exactly. And there's this brilliant syrup experiment that shows this predictability beautifully.
The syrup experiment.
Yeah, you put some drops of dye and thick, viscous syrup between two clear cylinders. Then you slowly rotate one cylinder. The dye stretches out, mixes into the syrup, right?
I mean, it makes sense.
But then if you slowly rotate the cylinder backwards, exactly the same number of turns, the dye droplets magically reappear. They return to their original position.
No way, it unmixes.
It looks like it's rewinding time. It happens because the thick syrup flows in these distinct, separate layers that don't really mix much. It's like the Sigur said, toilet paper laying in layers, or like fanning out a deck of cards and then putting them back. Exactly. Predictable, reversible flow.
But then, just a simple shake. Or maybe you speed up the rotation. And that perfect laminar flow just breaks into chaos.
That's turbulence. Suddenly you get vortices, swirls, unpredictable mixing. It's everywhere, from cream in your coffee to smoke from a chimney, even the air currents from our breath. The Kármán street, that's a great example, won a Nobel Prize. Understanding the repeating pattern of swirls you see behind an object in a flow, like a rock in a stream, or even behind an airplane wing.
Okay, so patterns within the turbulence.
Sometimes, yes, order can emerge. And here's a really counterintuitive fact from the research. Scientists actually proved that a dead trout...
A dead trout.
Yeah, a dead trout can effectively swim upstream against a current if it's positioned right. It uses the energy from the vortices, the swirls, created behind a rock in the stream. It kind of gets pushed along by the chaotic flow pattern.
That's amazing. A dead fish is exploiting chaos.
It shows that chaos isn't just, formless mess. It contains these complex, sometimes predictable patterns that can even be harnessed or exploited.
Yeah.
And this idea connects right back to the Nagasaki bombing. Kokura was the initial target that day.
Right, you mentioned Kyudo was the original overall target, but Kokura was the primary for that specific mission.
Exactly. But they couldn't bomb Kokura because the weather deteriorated rapidly. Clouds, smoke from earlier firebombing raids. Basically, turbulence mixed up all the cards.
Oh, the weather again.
Yep. That atmospheric turbulence and visual obstruction forced the bombers to divert to their secondary target, Nagasaki. Chaos saved Kokura, but tragically doomed Nagasaki.
This leads us perfectly into another really fascinating concept. Order actually emerging from chaos. Specifically something called strange attractors. Sounds like sci-fi.
Chuckles. It does sound a bit sci-fi, doesn't it? It literally translates to something like strange puller. Basically, it's a hidden underlying pattern or shape that a chaotic system tends to evolve towards over time.
So the path itself is unpredictable moment to moment.
Right. Totally unpredictable.
Yeah.
But the system's overall behavior, where it can be, is confined to this complex shape, this attractor. Think of it like a moth fluttering randomly around a lamp. Its exact path is erratic, but it stays near the lamp.
Okay.
The most famous one is the Lorentz attractor. Came out of early computer models of weather.
Weather again.
Always weather.
Yeah.
When you plot thousands of points, each representing slightly different starting weather conditions, temperature, pressure, wind speed.
Yeah.
They initially scatter all over the place. But then, over time, they all converge and trace out this distinctive butterfly-like figure, two interconnected loops.
So that butterfly shape defines the sort of boundaries for Earth's possible weather states. The combinations of temperature, pressure, humidity that can exist.
In that simplified model, yes. That's the idea. It represents a strange, perverse, but known form of order amidst unpredictable chaos. It shows the limits, the banks of the river, even if the water's flow is wild.
How can we visualize this? Pretty abstract.
Well, the material describes this great physical model to make it tangible. A carousel with leaky cups on it.
A carousel with leaky cups.
Yeah, imagine water dripping into these cups, making the carousel spin, but the cups also leak, making it slow down. The spinning becomes irregular, chaotic. But if you plot its rotational speed on two different coordinates,
Let me guess.
you get the exact same butterfly-shaped strange attractor as the weather model.
Wow, that's incredible. A physical system showing the same abstract pattern.
Exactly. And it really demonstrates the butterfly effect, too.
How so?
If you set up a second identical leaky carousel, but start it with just a tiny, tiny difference in its initial position, like thousandths of a degree difference,
Uh-huh.
their rotations will look similar for maybe a few spins, but then they'll behave completely differently. They diverge rapidly. This physical analogy really helps you kind of feel the chaos and shows these principles are universal, not just computer artifacts.
Okay, so strange attractors show hidden order. And then we have fractals, described as the universal language of everything and the mathematics that finds patterns in chaotic motion. What are fractals?
Fractals are these amazing geometric shapes that have self-similarity across different scales.
Self-similarity, meaning?
Meaning they look roughly the same no matter how much you zoom in or zoom out. Think of a coastline, or a fern leaf, or the branching of a tree. Each smaller part resembles the whole.
Right, I can picture that.
There's this cool experiment described. You take a triangle, pick a random starting point inside it. Then you randomly roll a die, say 1 or 2 means move halfway towards corner A, 3 or 4 towards corner B, 5 or 6 towards corner C.
Okay, sounds random.
It is. Each step is pure chaos, totally random based on the die roll. But if you just plot the points where you land and you do this thousands, millions of times,
What happens?
this incredibly intricate, ordered pattern emerges all by itself. A shape called the Sierpinski triangle, which is a classic fractal. It just appears out of the randomness.
So complex order from simple random rules repeated over and over.
Exactly. It shows how structure can arise spontaneously from chaos when there are underlying rules being iterated.
So this makes it sound like chaos isn't really random at all then.
Not pure structureless randomness, no. It's a very complex form of order. It's governed by underlying deterministic rules, even if the outcome seems random locally. Fractals are like the geometric signature of those rules.
They reveal the hidden patterns.
Precisely, within what looks like just disorder.
There was another great example in the material, the baker's transformation, with dough and raisins.
Ah, yes, the baker's map. It's a great analogy for mixing. Imagine a lump of dough with a few raisins in it. The baker rolls the dough out flat, stretching it, then folds it in half and rolls it out again, and folds it again.
Like making pastry.
Exactly. Each time you stretch and fold, you're basically doubling the distance between nearby raisins along one direction while squishing them closer in another. Do this repeatedly.
The raisins get spread all over the place.
Very quickly, yeah. Their positions become rapidly randomized throughout the dough. It's a vivid way to show how chaotic systems can rapidly disperse initial conditions, how mixing becomes essentially irreversible very fast.
And what about those thousands of rubber ducks? Ones that fell off a ship and traveled the oceans for like 30 years.
Oh yeah, the friendly floaties. Their journey seems total random, right?
Yeah.
They ended up washing ashore in wildly different places: Alaska, Indonesia, Australia, South America, even Europe.
Seems completely haphazard.
It does. But the insight here is that these seemingly random routes are actually governed by the incredibly complex, but ultimately deterministic patterns of ocean currents. Patterns influenced by factors going way back, maybe even laid down since the Big Bang, in a sense.
So even that apparent randomness, over long enough timescales, reveals underlying deterministic, though chaotic patterns.
That's the idea. It's not just random drift. It follows the complex, fractal-like pathways of the ocean currents.
And here's a really crucial connection you mentioned earlier. The strange attractor for the weather, that butterfly shape.
Yeah.
It's also a fractal. What does that mean for us, practically?
It explains something fundamental we all experience. Why do seasons repeat with, 100% certainty? Autumn always follows summer, winter follows autumn. That's the attractor, the overall bounded pattern.
Right.
But why is this autumn never exactly identical to last autumn? Why is today never exactly the same as this date last year, weather-wise?
Because of the fractal nature.
Exactly. The fractal nature of the attractor means that the weather's trajectory, while it's constrained within that butterfly shape, it never exactly repeats itself. It wanders infinitely within those bounds without ever crossing its own path.
The lines on the graph never cross.
Precisely. It ensures that the weather, while following a pattern, is continuously unique, always slightly different.
Okay, so the order we find in chaotic systems isn't simple repetition like a clock ticking. It's a much more complex, non-repeating, but still bounded geometric structure.
You got it. Fractals give us the mathematical language and even the visual language to describe this incredibly complex, unique kind of order that hides within chaos. They're like the internal imprint of the chaotic process.
Yeah, we see them everywhere in nature, you said.
Everywhere. Clouds, lightning bolts, river networks, mountain ranges, the branching of trees, blood vessels, coastlines. Nature seems to use fractal geometry all the time.
So let's know back. What does all this chaos, butterflies, attractors, fractals, what does it ultimately mean for our big starting question about fate? It sounds like it's neither fully fixed nor fully random.
Yeah, the material we explored, it really seems to redefine fate. It's not some rigid, pre-written script handed down from on high. It's more like this complex interaction between the underlying deterministic laws of physics and this pervasive influence of chaotic sensitivity, the butterfly effect.
Right.
Tsutomu Yamaguchi's incredible survival story, surviving 2 atomic bombs, it perfectly embodies this, doesn't it? It's like the golden mean between absolute predetermination and just pure dumb luck. There's a mathematics behind fate, but it's incredibly complex and sensitive.
And it really seems like our own human decisions, even seemingly small ones, can genuinely act as those powerful butterfly wings in history, changing the course of events.
Absolutely. Think about Henry Stimson saving Kyoto because of a honeymoon trip he took 52 years earlier.
It's mind-boggling.
It's such a powerful example of how individual choices, even ones based on sentiment, things that seem trivial at the time, they can become these critical initial conditions that fundamentally reshape global events, affecting millions of lives. It tells you that your choices, your actions, they do matter, often in ways you can't possibly foresee.
Which implies that even with all our amazing science, all our computing power, there are just fundamental limits to predicting the future, aren't there? Could you elaborate a bit more on why? Is it purely our inability to measure perfectly? Or is there something deeper stopping us from being Laplace's demon?
That's a great question. It seems to be more fundamental than just needing better instruments. Yes, the practical impossibility of predicting things like weather beyond a couple of days stems directly from that exponential amplification of tiny initial errors, the butterfly effect.
Right.
But the sources suggest that even if we could somehow measure initial conditions 1,000,000 times more precisely than we can now, the butterfly effect would still win out eventually. It would just push the prediction horizon out a little further, maybe a few more days for weather, but you'd still hit that wall of unpredictability.
So it's inherent in the system.
It suggests an inherent, irreducible element of unpredictability baked into the universe, at least in these chaotic systems. It's like a feature, not a bug we can eventually fix with better tech. It's a limit imposed by the nature of chaos itself.
So if the future is fundamentally unpredictable in any practical, long-term sense, what does that mean for how we should live our lives? This really brings us to carpe diem, doesn't it?
It really does. That ancient Roman philosophy, carpe diem, usually translated as seize the day, but maybe better as seize the moment. It takes on this profound new meaning when you think about chaos theory.
How so?
Well, the full quote from Horace is actually, "While we speak, envious time is flying. Seize the moment, trusting as little as possible in the future."
Trusting as little as possible in the future.
Wow. It directly mirrors this inherent unpredictability of chaotic systems. It highlights the potential futility of relying too heavily on long-term forecasts or rigid plans. It's an ancient wisdom that resonates perfectly with this modern science focus on the now, because the future is fundamentally uncertain.
And Tsutomu Yamaguchi's life, after surviving 2 atomic bombs, that seems like the ultimate embodiment of this philosophy.
And it truly does. He didn't just survive, he lived. He went back to work eventually, raised 2 daughters, even wrote a book about his experiences, poems too, lived to be 93.
Amazing.
He didn't constantly complain about his unbelievably harsh fate. He seemed to embrace the present, living a well-lived life despite enduring these extreme, unpredictable, horrific events. He seized the moments he had left.
Which brings us to where this deep dive really culminates, I think. It's not about despairing over unpredictability, but finding empowerment.
Exactly. We've journeyed through how reality is this complex, fascinating blend, underlying deterministic rules, yes, but overlaid with this undeniable, pervasive unpredictability, chaos theory, the butterfly effect, strange attractors, fractals. They give us the scientific language, the framework for understanding this constant dance between order and disorder.
And even with our best science, our most powerful computers, that fundamental mathematics of chaos means there will always be things we can't predict, unexpected turns. Our dream of calculating every particle's future seems fundamentally limited.
It does.
But that gives us room to maneuver, doesn't it?
It absolutely does. And that's not a reason for despair. It's actually, I think, a profound call to action.
Yeah.
Digging into the butterfly effect reveals something really significant: your individual actions. However small or insignificant they might seem to you at the time, they have the genuine potential to initiate significant, unforeseen transformations, both in your own life and maybe even in the wider world.
Think about it, right? That butterfly wing flap. Yes, it could theoretically start a hurricane somewhere down the line, but it also has the potential to stop one from forming or nudge things in a completely different, maybe better direction. Cuts both ways.
That's a fantastic point.
It transforms unpredictability from just a source of anxiety into maybe a catalyst for agency, for action. It's about realizing you can take that first step, seize this moment, and recognize your own personal influence, however small, within this incredibly complex, constantly evolving system.
Beautifully put. This perspective really encourages us to embrace the uncertainty, not fear it, and to recognize the inherent power of our own initiative. Your actions, even the tiny ones, they ripple outwards. Maybe you can't predict exactly how, but they do matter. They change the initial conditions.
So the next time you feel overwhelmed by the unknown future, maybe you remember the universe's inherent unpredictability and the surprising immense power hidden in your own small actions today. What will your butterfly do? Thanks for taking this deep dive with us today. We'll catch you next time for another exploration into the fascinating world of knowledge.